The first modification I've made to the scene is that I've deleted all the parameters from the intersection HDA. What we currently have is an intersection that takes 3 roads. What we are now going to make is an intersection that can take an arbitrary amount of roads. We also have a slight bug which I have not yet dealt with. This bug affects the start points and the end points. This bug comes from using the reverse cross-sections option in the sweep node. You can avoid this bug by using a different method to reverse the normals, but this will show you a solution if you are reversing geometry. I will now duplicate 2 of my roads, and I will clear the data from the test curves. I will then draw 2 more roads. These roads will be drawn pointing away from the intersection. This is the opposite of how I drew the original road. We are now able to update the intersection as well as show the problem. First, I'm going to turn on the point numbers. The way this system works is that the points need to be numbered in the same direction, and I prefer this to be clockwise. So on this new curve we would want our points to be numbered 0, 1, 2, 3 instead of 3, 2, 1, 0. Both of the new roads I've created have the point order in the opposite direction from what I require. The fix for this is simple. To do it, we will enter the intersection, and then we will add a sort node. I will attach the sort node to the start points branch, and then I'll set the sort node to reverse the points. We will now rebuild our parameters. We will need to open the type properties. We will add a folder, and this folder will be called roads. Next, we will add a few parameters to this folder. The first will be an operator path, and this we will call road. Then we will want an integer, and this parameter will be called refine. We will want another parameter, and this one I will place before the refine. This will be my start-end parameter. Then I will add a float parameter, and this will be my distance parameter. I have not yet set up the start points and end points correctly. The type will be an ordered menu, and under the menu tab I'll set the token to 0, and this will be endpoints. Next, I will make token 1, and this will be start points. When we are finished, we click Apply. What we have now is basically the same parameters that we had before. The primary difference is they are now all under one folder. This folder is going to be changed. We will set the folder type to multi-palm block list. When we apply this change, our parameters will go away, and we will get a parameter called roads, and this parameter will have a value of 0. We can use this parameter to add our roads. The roads will need to be added in order in a clockwise direction. I will start with 3 roads. To do this, I will click on the plus icon 3 times. I will do my initial testing with the roads which we originally used. So I'll add road 1, road 2, and then road 3. I will leave roads 4 and 5 till later. We will go into the intersection node. Nothing in the intersection node will now be working because we have deleted the old parameters. However, I will copy the first input section, and this will serve as the basis for our updated network. In order to add multiple roads, we need to use a for loop. And this for loop will be a for each number loop. The for each number loop will not loop over geometry. Instead, it will iterate over a sequence of numbers. Now, the object merge node does not work inside a for loop. You can, however, connect it to a for loop. And the way I prefer to set this up is to use a merge node. So we will add a merge node, and then we will connect it to the for loop and connect the object merge to the merge node as well. We will then connect the blast nodes to the merge node and patch the remainder of the network we copied into the for loop. Select the end node of the for loop, and in its properties there will be an iteration value. We do not want this value to be more than the number of roads we have, so drag and drop the roads parameter and set it as a relative reference. This means that the loop is now controlled by the number of roads we have. In our object merge node, we will delete the old values from the object channel. We now want this value to be based off the road parameters. However, if I just drag and drop the value, we will only reference one road. If you look at the reference that has been created, you'll see that the parameter has been given a number. The multiply block folder creates numbers for each of the parameters. So these parameters will actually be road 1, road 2, and road 3. To loop over this parameter, we need to remove the number from the reference. We will then need to add to it, and what we will add to it is the iteration of the for loop. We will get this value from the for each count node, where it is stored as a detail attribute. If we go to the geometry spreadsheet and look at our detail attributes for this node, it will list the current iteration that the loop is on. So we'll want to get this detail attribute, but we will also have to take into account that the loop will start at 0. So we'll need to add 1 to the value of the iteration. So it is the detail attribute. It is the for each count node. The attribute is iteration. And there is only one value in the index, so the index is 0. If we now select the end of the for each loop and return to the scene view, we should see all the points for our road ends. There are quite a few things that we still need to fix. The blast node should be fine, but the switch node will no longer work, which is why we have the exclamation mark next to the node. So we will clear the channel. This will be a similar process to the object merge node. I will have to open my parameters again. We want this to be driven by the start points at endpoints, but it also needs to work with the for loop. So we will drag and drop the relative reference, remove the number from the end, add the detail parameter plus 1, and set the detail attribute to be the iterate value from the for each loop count node. I then test to make sure my network is working properly. The solution I used to calculate the intersection edges will no longer work. I was using a detail attribute to store the number of points, and this has two major problems. The first is that detail attributes do not really store arrays that you can iterate over. The second is that it is very difficult to iterate over multiple detail attributes, so we'll use a different and much simpler method instead. So I'm just going to delete this attribute. Before we do anything else, we will have to reconnect more of the old network. In this case, it will be the basic intersection and the convert line nodes, which I will copy and paste into the new network. We now have our intersection again, and we've converted the lines into primitives. If we turn on the primitive numbers, we will see that the number of each intersection is the same as the point that follows it. This happens to be the first point of every road. Because of this, we will create an attribute for the first point of every road to mark that it is linked to an intersection. In our attribute wrangle node, we'll need to create an integer attribute, and I'll call this attribute intersection. The value will be set to 1. If the point number is equal to 0, the intersection attribute will now be set to 1. In my geometry spreadsheet, I will look at the point attributes, and my intersection attribute is not showing up. This is because I forgot to set the attribute wrangle node to run over point attributes. We should now have intersection points for the start of each road. Next, we will want to create a group for the intersection primitives. We'll add an attribute wrangle node after the convert line node. If the intersection attribute is equal to 1, then we will create a primitive group. To look up the vex function we need, we will open up the help. We will click on the vex topic, find the reference section and select vex functions. Then we will look for the group functions. And what we want is the setPrimGroup function. setPrimGroup. We are not referencing any other geometry, so the geo handle will be 0. I will name our group intersection edges. Then we will want our primitive number, which will be the same as the current point. So this will be at ptnum. A value of 1 will add to the group. And finally, our mode will be set. If we look at our groups now, we should see that we now have an intersection group under the primitive groups, and that should be a group for all of our intersections. We can now get 2 blast nodes. We will set them to have intersection edges as the group, and one of the blast nodes will be set to delete non-selected. We have now separated our primitives in the same way as in the previous network. So we can now delete the input sections of the previous network and connect the loop section with our new network. We're now almost back to a working network, but there are a couple of things which are different from our original network. The first is that we no longer need this attribute wrangle node, so we can now delete it. We'll start updating the nodes in the network with the resample node. We'll also need to get the HDA parameters. And now we can remove the expression from the segments channel. We want to drive our resample node with the refine parameter. The refine parameter, however, currently starts at 0, but it should start at 1. We will open our type properties. We will change its start value from 0 to 1, and then we will lock the lower value of the range settings. While we are doing this, I will also change the distance to accept negative values. Now I will drag and drop the refine parameter onto the segments channel. We will work with the same equation as the other for loop, but I do not have any of the data for this loop. To get the iterations, we will select the for each begin node, and then we will press the Create Metadata Import Node button. I'm going to rename this node In the resample node, the equation will once again add the detail iteration plus 1. I'm still not happy with the metadata node name, so I rename it again. The next node to change is our attribute promote node. Since we've deleted the attributes this node refers to, we can delete this node. The last part of the loop that we will need to update will be the attribute wrangle node. There is no longer a curvedist attribute. We will instead change curvedist to a float variable. Instead of trying to connect the distance parameters directly with vex, we will instead create a local parameter called curvedist. We can then drag and drop our distance value onto this parameter, and the equation will once again be this plus the iteration detail of the count node plus 1. I now do some tests to make sure the basic intersection loop is working. I'm now ready to delete the attributes I don't need. Only I've discovered I've misspelled intersection, so I correct that quickly. I place an attribute delete node just before my blast nodes. I will use this delete node to delete the intersection attribute. I will then place an attribute delete node after the for loop, and I will delete all the attributes apart from point position. I will then link the polyfill parameters to the HDA again. Finally, I will test the intersection with all of the roads.